Hello, folks. How are you once again? Yeah, for sure, the proper decision of an appropriate statistical test to use while intending to analyze your data is a problem among you guys. I realized this because of the question that I was receiving from some of my friends whom they were trying to send me their questionnaires, their raw data to help them to make analysis. And I came to realize that some of you guys, they used to send me the raw data of their findings with the predetermined statistical test. You may find somebody is asking you, please, sir, can you help me to make analysis of my data? And I want to use the t-test as an analytical tools. Or I want to use f-test. I want to use one-way ANOVA. Once you receive the package of data and the question that we are asked, or the hypothesis, you find they are not telling each other. The assumption that are running from particular, maybe for chi-square test, and the questions or the nature of the data that has been supplied by the particular individual, they are totally irrelevant. Therefore, instead of trying to explain this to each one of you, I found it's better if I provide this a kind of lecture from which you'll be in the position of describing each of these statistical tests, and then you will decide which one could fit to your kind of data, which one will fit to your nature of data, and which one will fit to the nature of your study. I am going to explain each of these methods within 20 minutes or 15 minutes, a clear and direct to the point that you will not long engage yourselves into confusions of which statistical test to use when I want to make analysis of your data. That's why I came to this heading, deciding a statistical test for your data. How to choose an appropriate statistical test for making analysis of your data. It is a common statement to hear from some of you stating, when they have data in hand, you may find somebody stating, oh, I will analyze my data using parametric tests. Or I will use my data, a so-called non-parametric test to make analysis. Some, they can say, I will use the dependent t-test. I will use independent t-test. I will use the chi-squares or the f-test. I will use one-way ANOVA. For me, guys, I will use factorial ANOVA. I will use multivariance, Markova. I will use covariance. I will use Pearson or Spearman's correlation. I will use regression, simple linear regression or multiple linear regression. So they state such a statement without even knowing what is the assumption behind a particular test. So it's very important to understand this before you decide for the particular test on your data. Stating this statement without knowing the assumptions or the conditions that apply for a particular statistical test is what it can bring you to what we call an academic wrapping. That you are wrapping the statistical point of view, because your data might be not normally distributed, and we are going to use a parametric test which requires a normality kind of data. Your data might be normally distributed and has all the conditions that fits for a parametric test, and then you are going to use a square test, chi-square test, which requires a non-parametric data, and it should be nominal in nature. So such complications is not clear among of you guys. That's why I am bringing to you this kind of information so that you won't get any contradictions on this particular statistical point of view. I will not go deep into statistical terms. I will use the common ones because I know you are from different fields and from which is easier for you to decide which method is good for your kind of study. All right. Before I go into detail, let me highlight some of the common statistical tests which are commonly used in the current world. We have been several of these statistical tests, and most of them they have been even incorporated in some analytical softwares. Most of the software will find all these statistics are incorporated in. When you are using SPSS, you will find in them. When you are using the SAS, you will find in them. When you are using MATLAB, you will find. When you're using other software, you will also find. And whatever the kind of statistical software that you're using, you will find these statistical tests are incorporated in it. The difference is how you manipulate from one statistical software to another. And these statistical tests are categorized, as I said, into two groups. We can call them as parametric tests, and some are referred as to non-parametric tests. I will explain you to later in minutes to come what is parametric and what does it, but not in the detail. I will have a separate video for their detailing. The common test, we have the so-called simple descriptive statistics. Under this particular test, you're going just to give the description of your star. What is the mean? What is the median? What is the range? What is the covariance of variations? Those are the descriptives. We are talking about the central mean of tendency and center of dispersion. It might be the independent t-test or dependent t-test. These are the common. We have the chi-square test. We have the one-way ANOVA. We have the factorial ANOVA. We have the Markov means, matvariance, covariance. We have MANOVA, matvariance. We have Pearson. We have Spearman correlation. We have regression analysis, where we may be having the simple linear regression or multiple linear regression. And we have sometimes we carry out correlation and the regression analysis for predictive kind of study, we'll see. And we have multiple response analysis. We have content analysis and other more statistical point of view. But what should you know before deciding for a particular test that I'm going to use this particular test for my data? There are some two questions you need to ask yourselves. That's why I say, before making any decisions as to which proper statistical test to use while making your data analysis, you need to answer the following questions. Question number one, and this is the question that will be directing you to a particular statistical method we opt for data analysis. The first question is the nature of your data. What kind of data you have? Are your data, take this pen. Where's my pens here? Good. You need to know the nature of your data. Is my data parametric in nature, or my data is non-parametric? Okay, that's a question, the first question you need to know upon the nature of your data. And when we speak about parametric and non-parametric, for the simplest point of view, when we speak about the parametric data, the assumption behind is the data are normally distributed, are approximately normally distributed. We know the normal distribution curve. And we assume that the data are less or no outliers. The data are highly homogeneous. There is an equal variances, and even the sample size might be considered. And we believe that the data to be parametrics, it should have the larger sample size. The larger the sample size increases the possibilities of your data to be parametrics, even if it was not parametric in nature. The size, we can go to this large sample size theory. The data should be numerical in nature. These are some of the assumptions that provide the idea that my data is parametric in nature. And this parametric data, it has, if your data is parametric, then you have some special statistical tests which measure parametric kind of data. And if your study, for example, is for comparison, you are going to make a comparison of some variables of your study. You will use simply t-test. It may be independent t-test or dependent t-test. And a comparison, where and a t-test, maybe you are going to compare only two parameters or two groups. If you are having more than two groups in comparisons, where you go for one-way ANOVA. You are comparing two different groups under the same parameter to be measured. If you are comparing more than three, if you are comparing more than three parameters, then one-way ANOVA came in, two-way ANOVA came in, three-way, four ways, and etc., which we call factorial analysis, and other more statistical tests. So these are the statistical tests which are used when your data is parametric in nature. When you are doing a study related to correlation, means we are going to find out the relationship between two variables, and even looking on how one variable influences the other variables. How either the dependent variable influence dependent variable. How variable A influence variable B, or the relationship between this and this, A and B. Such kind of study, if your data was in a parametric in nature, we use Pearson correlation test. And the vice versa is true. When your data were not parametric in nature, that they were they violated these assumptions of normalities, homogeneities, heteroscedasticity, and so on. Therefore, meaning you are going to use a so-called non-parametric test. What are the examples of this non-parametric test? When you are doing a study related to comparison, as mentioned here and above, instead of using the t-test, two-way, and ANOVA, and the other forms of ANOVA, we are going to select the so-called Mann-Whitney U-test, which is within the whole post of the statistics. We are going to use the Mann-Whitney U-test, or sometimes we use the Wilson length sum test correlation. These are the ones that they make use of the rank. And under non-parametric test, maybe your data is in categorical or in nominal nature, which do not obey to the idea of numerical kind of data. That you are ranking your data into order, maybe from 10 to 20, male and female. Such kind of data, they cannot obey to the use of this parametric test, where you need to go for non-parametric test, of which Mann-Whitney U-test will be used for comparison, and Whitney signal length sum test. These are the common. There are several, but these are the common which are said to be more powerful. When we are looking on correlation and the relationship or predictive kind of study, we are using Spearman instead of Pearson. And we also use chi-square test. Therefore, the deciding when we start speaking about, I'm going to use chi-square test, I'm going to use the Spearman test. You need to conceptualize in your brain that, okay, when you speak up of the chi-square test, what are the nature of my data that the question should bring up in your brain? What the nature of your data? It's not just speaking that I'm going to use this part of test. without knowing the assumption behind. And sometimes you might have your data is numerical in nature. And when you go to the concept of normality, they are not normally, approximate normally distributed. And you want to use parametric tests because they're so powerful to portray the characteristic of your data. Then it's not a case. What we do is what we call the so-called data transformation. You need to transform your data so that they fit into normality condition. That's where we carry out normality test in a particular software, a normality test, and where we find some of the tests that are very useful for testing the normalities, the Shapiro test and Skoskovicki test and other more. They are very useful. So you need, if you want to use parametric tests, such as maybe one-way ANOVA, t-test, independent t-test, and your data are not normally distributed, there is an option of transforming your data into normality. And you have several transformation types. You can go for logarithm transformation, square root transformation, arsenic transformation, and other more. I will explain this one to another in the next series. But there I'm trying to show you is why deciding for the proper methods or statistical tools for making analysis of your data, you need to consider these highlights. Another issue that we need to ask ourselves, the second question is, what type of research question or hypothesis do I have with my study? The kind of the research questions decide for the kind of the statistical test to be used. Suppose if your research question was trying to describe about a description, it wanted to come out with some hidden information within your data. You want to see what the mean, what the median, what is the range, what is the maximum value, and what is the minimum value. Such kind of information, what is the percentage? Maybe you are doing a study, you want to see who reported higher than the other. Maybe you are looking for the men and the female. And you have linked your data, maybe the strongest, less, I don't know, whatever, depending on the nature of the question. And you don't want to come up with other information, just you want to see which has contributed much than the other. You can go for what we call descriptive statistics. As I said, you're going to look for the measure of central tendency and the measure of dispersion. You're going to speak about the mean, standard error, standard deviation, the variance, coefficient of variation, the quartile range, the normal range, CVs, and other modes that are within whether the center of measure of tendency or the center of dispersion. Sometimes you may be doing a study which is asking about the comparison. Which groups or which treatments has higher productivity than the other? Which groups reporting this one had higher performance than the other? Which group of students performed well than the other? You want to make a comparison between two or more than two parameters within your study. If your study is more about comparison, therefore, you need to look for the comparison-related statistical tests. For example, these comparisons where you find this t-test, one-way ANOVA, two-way ANOVA, we call them factorial, three-way ANOVA, MANOVA, MANCOVA, and all other related. All these kind of tests are comparison. So the nature of your start question determines the type of statistical test to use. And while doing this comparison study, you need to understand that there are some common tests while getting maybe one-way ANOVA. When you go to the so-called post-hoc, when you open up a particular software, while deciding on a particular test to use inside the post-hoc. For example, you can find a Take test, Duque test when you're doing for comparison, for assumed means. You can go for games, word test, and other more tests, they are there. But my today's presentation is to tell you which test fits to a particular condition. When you are doing a study related to correlation, you want to see if there is a relationship between two or more variables. If one variable influences the other, and you want even to make predictions, predictives of a particular effect. Suppose you're doing a study on, you are comparing the GPA of students, maybe it's student A and student B, and you want to see what could be the performance of particular students in 10 years to come. If the GPA of this year is 2, then therefore you go for what we call a predictive kind of study, regression analysis. That's where you are going to do a Pearson correlation, Spearman correlation, chi-square test, and a regression analysis. So deciding of the use of this particular test depend on the types or nature of the questions that is with you in your study. Depending on this question number 2, we can now have in our mind that, okay, you can now try to assess yourself with your study. Okay, I'm dealing with 1, 2, 3, and this is my hypothesis, and this is my questions. Therefore, which could be the proper statistical test that would fit in my study? In so deciding, you need also to remember what we said before here, that should fit on parametric or non-parametric. On parametric and non-parametric, what are the conditions and what are the statistical method to be used? On looking on the objectives or the questions of your hypothesis or the study questions, these are the methods that you need to select. So it's not just the matter of saying, okay, I'm going to use t-test. T-test for what? If your study is not related to t-test, how are you going to use t-test? Why are you going to use a measure of central tendency? Why are you going to use a one-way ANOVA or two-way ANOVA, factorial analysis? Why are you not going to Pearson? So you need to know these things without making them confusing. Therefore, with this simple video, simple elaboration, I will be helpful for your decision. And I tell you that I will be taking you one way to another. I will be taking you how do we analyze this particular method, and I'll be using 2 different statistical software of which I am expertised. I can use the SPSS, which is also free, available. I will also be using the ALA software, which is also free, available. Both are free, available, and when I teach through those particularly website software, it will be easier for you to download and apply as it seems to be good for you. As I said that when you compare between the parametric and non-parametric tests, the parametric tests are so powerful and strong to display the relevant kind of information within your data as compared to non-parametrics. That's why most of the researchers intend or wish to use the parametric test. So if you find your data does not fit the parametric test, particularly on the issues of normalities, that's the big one, the issue of normalities, I advise you to do the so-called data transformation. You do data transformation. And before deciding to do a particular study, you need to test for data normalities. And that is easy and simple. And I can show you, let me use this simple time to show you how we can do this. How can we do this? We can do this. How can we do this? Suppose this is my SPSS. This is my SPSS window. And now from this SPSS window, I want to show you how do we do the so-called testings of the numerate of your data. That's simple. This is my data. This is maybe age. This is for any. This is for age. And this is for any. Okay, well, good. I simply go to analyze and then go to what we call descriptive statistics. I'll go direct to what we call explore. From here, what are you going to explore? I want to see the earnings if they are normally distributed. You can look for the statistics behind. I need descriptive statistics and the confidence interval 95%. You can look for the graphs. Which one do you want? I want the histogram to appear. Well, good. You can look for the other options if you find they're relevant for you. If you're not, you say no. You can go for the boost cut, of which is inactives, no. Then after which you say, okay, let me display. Now this is the outputs of the software. Yeah. On deciding on looking on the numeric of data, we have the so-called skewness and ectosis. That's a very important point from which we can decide whether your data are normally distributed or are skewed in either direction, either in positive or a negative skewed. That's why we have this skewness and ectosis. This is case summary. It will give you how many number of samples that were within your data and all those things. I don't want to explain now. It will tell you about the past confidence rate, will be the median, the variance, standard deviation, minimum, maximum, the range, the quartile. And what's important in this particular area here, skewness. And if you are not more aware of the skewness, we are talking about the nature of your data, you can go for the histogram that we selected. The histogram will tell you. From this, you can just simply use visual expressions that most of my data are rely on the left-hand side. That's positive skewness. So my data is not normally distributed. Therefore, with this kind of data, even if they were numerical in nature, I cannot opt for parametric test. Otherwise, I need to transform this data into parametric, or I can use the non-parametric test. But non-parametric tests, as I said, they're not powerful. The only option is to transport this data into what we call the numerarity. What can you do while transforming the data for numerarity? It's easy. You go now to your data, and you simply go to this particular area we call transform, not transport, transform. And you say, what do you want to transform? Now is here you are going to select the modality of transportation, whatever, but I'm not going to explain today this. I will have a separate video on how we can do this. Therefore, for this particular video, I am sure you will be a good person and you understand in deciding which statistical methods or test to choose in your data while deciding to make analysis. And I decided to say it because I do receive these questionnaires from other friends of mine. Some they send me this numerical data and ask me to carry their analysis for their data. And they even advise me, please, I want to use the chi-square. When you ask, do you know the reason behind the use of chi-square? I don't know. That's why the problems. With this particular video, I advise wherever you want to send me your questionnaires to make analysis, please make sure that you have prepared a good, this we call questionnaire list, questionnaire templates, and then you have coded your data relevantly according to your intended goals. It's not easy to me making a lot of calling, asking why this, what do you want, and this, what, and that will be cleaner and good for us to learn. That's good. Good day. Wish you all the best. If you find this video, I will also share in my YouTube. Then you can go through and recall as much as you can. Thank you for your times. Thank you very well.